So this session, it's going to be in about 3 segments. So we've got 2 10-minute discussions from thought leaders in moving people in smart cities. And then we've got 2 panels, and I'll introduce each of those panels as they come. But as is standard for the way I love to moderate a stage, the first 2 speakers, the 10-minute slots each, I'm going to tell really fun, quirky insights into them, because that's kind of what it's about. So Jamie Heywood, who is the regional GM for UK and Northern Uber, he was an extra in a Chinese movie when he was in China, and he played foreign soldier. How's that for a dramatic pause? And the movie was about the Opium Wars. I'm just going to leave it at that. Then Dave has also agreed to be my personal bouncer in case any of you guys are badly misbehaved. He used to be a competitive Thai boxer, so behave back there or else I'm going to sick Dave on you, okay? So with that, Jamie, I'd love to invite you to stage.
Enter foreign soldier. Is that okay? Can everyone hear me at the back? Okay, great. So what I wanted to do is spend 10 minutes talking a little bit about at Uber how we think transportation in cities is going to change and the role that we want to play as part of that change. So I want to start by maybe just taking you back 10 years. So 10 years where probably this tunnel did not exist, the King's Cross building site did not exist, before Boris bikes existed, when congestion and pollution was no longer one of the concerns that people had around getting around a city. There were 250,000 fewer bike journeys in London 10 years ago. There was no Uber, and nearly every 17-year-old believed getting a car was a rite of passage to adulthood. Now, in that time, obviously Uber has launched, and we now help over 3.5 million Londoners get around the city on a regular basis. And we're part of the fabric of helping London function. And we recognize that there are responsibilities that come with the growth that we've seen and with the role that we play as a part of London's infrastructure. And there's sort of 3 areas that we think where those obligations for us are very real and we take them very seriously. The first one is around reducing emissions. So it's around clean air. The second one is around reducing congestion, so stopping traffic jams or preventing traffic jams. And the way we really want to do that is our primary commitment, which is actually the cause of both of those, which is reducing private car ownership. Now, if we went forward 10 years from today, hopefully you'll be coming to the version of this in 10 years' time. I think one thing that's clear is that the way we transport people around cities now, which is based on private car ownership, is not sustainable. And there's 3 reasons for that. Firstly, it's environmentally unsustainable. So 50% of roadside emissions are caused by cars. And that affects city health, that affects life expectancies, that affects quality of life. Secondly, it's hugely expensive. So with the amount of time that Londoners spend in traffic jams, that costs London about £8 billion a year, which is about £1,500 per Londoner. So that's an avoidable cost that we are currently bearing because of the way people get around. And the third thing is it's a really bad use of space. So the average car park in London now costs £200,000, which is more than the average house in the UK. And when buildings are built now, they're built with 20, 30, sometimes 40% of space allocated to cars. Now that doesn't make sense for an asset that sits empty 95% of the time. Now, I joined Uber about 12 months ago, and the first thing I did was I went through the process of getting a private hire vehicle license. So I joined Uber and I started driving around the city. And what's really interesting as a driver is you see London from a very different perspective. You see how London breathes. So my first trip of the day would always be, I live in Crouch End, my first trip of the day would always be being pulled into central London on someone's commute. And then you get pulled out for the rest of the day and you're helping people live their lives and get around in London. So I drove nurses to the hospitals, I drove teachers to school, I drove kids and their parents back from school. I drove people to bars. I drove drunk people back from bars. I then drove back to the bar with the person to pick up the suit that he left, and then back home when he left the suit in the car, and I then had to do that. I mean, you feel how London lives, and you feel the city breathe through the perspective of Uber. So that was a great insight into, I think, some of the role that Uber plays as part of the fabric of London. But ride-hailing, so the UberX product, is not going to be enough. And I've also been very proud in the 12 months that I've been enrolled to start to broaden Uber's role in helping people get from A to B. So we were discussing earlier, we launched jump bikes in Islington a couple of weeks ago. We integrated buses and public transport and the tube into the app. So now if you're going anywhere in London, one of the options you'll have is public transport. You'll have accurate information about how long that will take and how much that will cost. And that will give you the choice as to how you want to get around. And we're also doing a lot of work to improve our pool service, which is our shared ride service, which is great for Londoners because by putting more people in one car, you reduce congestion, you reduce emissions, and you obviously therefore reduce prices for passengers while still making sure that drivers earn a fair wage. So what we're starting to see through this combination of building, working our way into the fabric of London lives and launching new modes of transport, is we're starting to see that people are giving up their private cars. Now, this is a trend that will take many years to work through, but the early signs are already available. Teenagers are currently 40% less likely to have a driving license than they would have been 10 years ago. 4 out of 10 Londoners say that they would consider not owning a private car and using Uber and other modes of transport instead. And a quarter of Uber users actually bring their baby home from hospital in an Uber. So we really are building ourselves into helping people live the lives they want to, as well as reducing congestion and emissions. So the process, which as I've said is going to be a long process of reducing private car ownership and meaning that people start to use transportation through the app and that the phone starts to replace the car. I wanted to take you through 3 things that we're doing now to help make that happen. The first one is around reducing emissions. So some of you may know, but we've made a commitment in London to, by 2025, make sure that every driver enabled through the app is in an electric vehicle. And the way we've launched that is through the Clean Air Fund. So some of you may have seen, as you've driven around at the bottom of your receipt, a small charge that we charge. And that money is going into driver savings accounts and accumulating to help drivers upgrade into electric vehicles. So we've raised currently for drivers £30 million to date, which is 15% of the way towards our aspiration of raising £200 million for drivers to help get them into electric vehicles by 2025. And although we're early on the journey, we're starting to see some good signs. So we've seen the number of electric vehicles on the platform increase by 300% this year, and we're already doing over 2.5 million kilometers of trips in EVs every week in London. So, a long journey, but a good start. The second part, the second thing we're doing to try and mean that people give up their private cars and replace it with their phone is just about giving people more options. So I've spoken about transit and integrating public transportation in the app. We've done that in London. We're looking to take that out further. I've spoken about launching Jump, which at the moment is in just Islington. We're looking to grow that. And I've spoken about Pool and our shared rides product, which again, is in London, and we'll be looking to try and grow that and change user habits about how people think about getting around the city. And we're also, in other areas that I look after within Northern and Eastern Europe, rolling out on-demand bus services and a range of other things to try and explore other ways of getting people around. The third thing is partnering for cities. So obviously we didn't always get it right. Uber's had a difficult 2 to 3 years as we've sort of had our license not renewed and then renewed. And the commitment that we are making, and one of the key things that I've been doing in my year, is to listen to cities and to make sure that they understand that we're a better partner and that we're part of the solution to the way to helping Londoners get around and improving Londoners' quality of life is not part of the problem. And one of the ways we do that is we share all of the data that we have on the app. So we share with TfL and other regulators and other third parties the data about all of the journeys that Londoners are doing every month, and that allows them to use that in traffic planning and other things. So to wrap up, the way we move matters. The way we move matters because it defines the air we breathe, it defines the shape of the city we operate in, it defines the way buildings are designed. And I think London is pioneering some of the changes there, firstly with some of the congestion charging and emission charging that has been introduced, which I think goes some way towards it, but it's going to be a long journey, and it's a journey that we at Uber are committed to being a good partner for. Thank you very much. Over to you.
Thanks, Jamie. And now I bring Dave Sweeney from from O2 Motion. Ouch.
Hello there.
Can we get the slides, please?
So you're probably wondering why there's a guy from O2 standing in front of you talking about transportation and moving people around. Hopefully by the end of the speech you might have some idea, and hopefully it's a good chance to see how times are changing. Here we go. So the reason being, it's all about our data. So mobile phone companies obviously need to know where you are at any point. So if you get a telephone call, you send a text message, we can connect you and we can give you that service. We take that mobile phone data and we anonymize it, we aggregate it, and we extrapolate it to give a really good understanding of crowd movement, of population movement. The data samples that we work with as a cellular company are vast, so 25 million customers across the UK. We actually also do this in 13 other countries across the globe in the Telefonica footprint. That 25 million customers produces 6 billion events a day on the mobile phone. That's across 2G, 3G, and 4G. When 5G is introduced, that number will really skyrocket. We saw a vast jump from in the introduction of 4G a good few years ago now. But what we do, we take that data and we process it into insights. So as you can imagine, the data that comes out of the mobile phone network isn't designed to be used for insight purposes. So it comes out in a very strange way, and it's not quite as simple as just literally pulling the data out, putting it on a database and saying that's where everyone is and that's how they're moving around. The cellular network is a big moving beast, and it's constantly balancing the network based on people's movements and capacity loading and so on and so on. So there's quite a lot of different techniques we have to use in order to understand how things work. But we've been working with this data now for a number of years, and we've started to build out a number of use cases. As you'll see from the slides there, we pull across demographic insight. Again, all anonymized and aggregated, so we're not actually tracking any individuals. The data we use is not classed as PII, which means we're not impacted by GDPR. We have persistent IDs on the data, so we can understand people's patterns and commutes and journeys of interest, places of interest. We process the data looking for specific specific patterns in the data to understand, for example, different modes of transport. So to put that into context, if you're traveling on a train with 100 other people, you'll all be handing over from one cell to the next at the same time. As you go through a tunnel and come out the other side, all of your phones will be reaching to the network to try to get a connection. So it's very easy for us to take into consideration the speed that you're traveling at, the speed the train's traveling at, with a clustering algorithm to say these people are definitely on the train. And we use a number of different techniques to identify lots of different modes of transport. We've done quite a lot of work in infrastructure. We've got some great projects that have gone way past proof of concept and rolled out with Highways England. It's probably our biggest and best product to date. We've built something called the Trip Information System, which processes a year's worth of data for the whole of the UK, and Highways England make that data available for different consultancies working on their transport modelling projects to understand demand and the way that people are using the strategic network. And they can literally split the data by, I want to look at 7 a.m. to 8 a.m. on every Tuesday for the year. Can make any type of cut of data by any mode of transport they want to do. TfL have done a very similar project. As you can imagine, when you start to work in a city like London, you introduce other problems within the data, so there's more people. The resolution of the data doesn't quite support the mobile phone network. There are more cells, there's more modes of transport. So the algorithms that we have to develop have been worked on over a number of years, but it's not enough within a city. So we take our data as a base layer, and then we use all TfL's data to overlay on top. So we're taking feeds from Oyster card data, iBus data. I think there's about 15 different data sources that we use to produce this model called Project Edmund, which again is available for planning purposes across the city. We've started now to develop the data into for real-time purposes. So all the stuff we did previously was retrospective based on historic data. Now we're starting to pull the data through in real time. Firstly, that does narrow down our use cases a little bit, because all the analytics we would apply to the data previously can't all be hard-coded in on the real-time platform. So we reduce our capability slightly. That said, we also open up all the different use cases to us. So if we're running with real-time data and we've got real-time traffic flow information, public sector can start to make decisions based off of that data. You can start to react to things that happen. You can start to look at specific events and make decisions across the network that can support all sorts of things. The other interesting thing about mobile phone data is it's multimodal. There are very few data sources that are used in transport planning or in traffic rooms that actually cover all the different modes. Mobile phone data is probably one of very few that holistically sits across all those different modes of transport. So the introduction of real-time data now has really moved us into almost a different world, and it's taken us into the smart cities world. So if you think about smart cities, two of the probably strongest verticals within there are the ones that there's a lot of interest about: transportation and then environment and pollution. Obviously, the two are quite heavily linked as well. So we started to move into that world, and when you start to break down the components of a smart city, it makes more sense for a phone company to be involved in it. So obviously we already do the data piece. Connectivity is going to be a huge part of any smart city. You know, things need to happen in real time, very low latency. So again, it fits. If you think about the partners that telcos have, the people that provide our networks, the hardware, the software, these companies are all the same companies that are providing a lot of IoT devices and a lot of IoT solutions. So we're very well placed to start working in this sector. The first project that we're working on in the smart cities world is one called the Thames Valley Live Labs, and it's a project that we're leading on, and you can see all the names of the different partners that are involved. It's heavy input from public sector, so it's right across the Thames Valley region, and the main study area will be Berkshire. I've got to go really fast now because I'm running way out of time. I'm going to quickly talk about some of the use cases that we're running. So we're looking at 5 different use cases: potholes, energy, air quality, traffic flow, and health. And in each solution, we're taking different partners, different complex models to work out and give ourselves different results. But the whole purpose of this is to say, all these products, all this technology, all works in the lab, but does it work in the real world? So, for example, the pothole one's very obviously a massively sexy topic, but a huge problem for public sector, whether it's noise pollution by lorries rumbling over the holes, whether it's the damage that's caused, or whether it even causes accidents. We're putting devices on board some county vehicles They drive across, they show us where the potholes are. We then take the mobile phone data to create a priority matrix to say, these are where all the potholes are, these are the ones you need to fix first, because these are the roads that are used the most. The second one is air quality. One of our partners is Siemens, who run all the traffic light systems. We're putting air quality sensors on the traffic lights so that we can help to understand what the pollution levels are like. Again, we reference the mobile phone data, which gives us an understanding of this is the quality of the air at these times of day in these areas, and these are the people that are exposed to it. So again, it starts to give us some interesting data. The output of that is to start to share that information with the citizens, with the public, to say, would you make a different decision about what time you travel or what mode of transport you use if you knew this was the case? And the final one I wanted to speak to, sorry, I knew I'm running a little bit out of time, is traffic congestion. So congestion is a massive crippler for the economy. If we can start to use data to improve the way that roads run, that traffic flows, then it's a massive step in the right direction. We're pulling through real-time mobile phone data. We're also taking data using IoT connectivity out of the traffic lights in order to start to optimize the traffic lights so we can move the traffic flows much quicker. It's widely thought that traffic lights were optimized, but it's all done on historic and it doesn't react to any situation that's around. So can we do it all in the real world? What does it look like? And then once we understand the learnings and we're starting to communicate to the citizens, how does it scale up and can we actually turn it into a smart city? Hopefully we'll have the answer in 2 years. Thanks.
Thanks, Dave. You've got a good audience out there. So next up, we're going to have 2 panels. The first one is going to be on data and people moving. And then the next one is going to be on new uses of data and services. But before that, I'm going to ask you guys to do something funny. I want to take a picture of everyone because it's kind of fun. So can you all make faces, wave your arms, do something silly? Because, the photographer's going to do it and I'm going to do it with my iPhone. Come on, guys, on the count of 3. 1, 2, 3. Come on, yay. One more, come on. 1, 2, 3. Come on. There we go. That's good. I like that.
I guess
it's such a cool venue. We have to get some kind of cool photo. Hopefully that worked for you as well. Cool. Okay, so next up, the moderator for the next 2 panels is Andrew Eland from DeepMind. Now, Andrew right now leads the DeepMind team of software engineers that are bringing technology to Google's NHS partners, which is phenomenal. But actually, he used to run Google Maps in the UK, so he knows what he's talking about. I think it's fair to say. Now, again, quirky fact about Andrew is he bakes 2 loaves of sourdough, what is it, a week?
A week, yeah.
A week, right?
Sometimes a day.
Yeah, sometimes a day. And he showed me a photo, and it looked quite delicious. I'm quite upset you didn't bring any for us backstage. I'm like, I don't know.
Meet me afterwards, and we'll.
Yeah, fine. And he also makes homemade jam, which I think is quite cool. So with that, the panel on data and people moving. So can I get the other panelists up, please? And over to you, Andrew.
Thanks, Mindy. Thanks, everybody, for joining. So we're going to have a discussion here with Dave and Jamie, who we've just heard from. Also, I'd like to welcome Clare Fram to the stage, product manager at Arup. I think maybe to start, perhaps, if Clare, you could introduce Arup a little, because obviously not having given a little talk and not being a technology company, I'm not sure how aware people in the audience will be of the firm. So it would be great to hear a little bit more about the firm and your role there.
Wonderful. Really good to be here on kind of Andrew's white couch. I'm Clare Fram. I'm a product manager at Arup. If you're not familiar with Arup, we are a global company of more than 14,000 designers, engineers, consultants, planners. It's really easy to talk about Arup here at this venue because Arup was involved in a lot of the King's Cross and Coal Drops Yard work. King's Cross is a great example of planning, IT work, engineering, all coming together to deliver kind of a final product. My particular role as a product manager is a little bit of a new area for Arup, but in many ways fits in with the work that we've always done. The product that I am managing currently is Mobility Mosaic. So I'm working with our transport team who are really trying to who've identified a gap. Our clients were trying to understand how people are actually moving around cities so that they can plan infrastructure that meets, right, user needs, human-centered design. We know that's so important. And the way transport consultants do that, or have traditionally done that, is using whatever data is available to them, which could be census data or pen and paper surveys, or might have some kind of information about supply, so particular vehicle fleets or transport use, but not necessarily the overall kind of end-to-end. So that is a little bit about me and why I'm here.
Thanks. Fascinating talks from Jamie and Dave. One of the things that interests me personally, having worked on mapping systems for many years, is how transportation actually has the power to change the environment around. And we talked a little bit earlier in your talks about how data can do that, and I think there are a couple of concepts that you mentioned during the talks I'd like to pick up on. One is on the real-time aspect. You know, traditionally transportation planners have measured people and bicycles and cars by going out on the streets with pens and paper. And now presumably the products that both Uber and O2 are working on give you much more kind of accurate real-time counts. And I was wondering how that kind of changes the transportation planning process in your minds. Perhaps start with Dave.
Yeah. I mean, I think the benefits are endless. You know, we talked about the reduction in congestion. I think all of it starts with understanding the situation now, understanding what's going on, and using the data and the insights to build up that picture. But ultimately, it's good once you understand the position and the situation, you can then give the citizens information and let them make decisions based on the real data and the real information that could potentially, you know, change what they're doing, maybe change the mode of transports that they're using, and that sort of thing. So I think ultimately, you know, the end results and the benefits are all directed at the citizens.
Jamie, how do you feel about that?
So obviously, I mean, for those who've used Uber, it's a very real-time service. You get your ETAs, and it works. I think the interesting thing, one of the interesting things we've been grappling with this year is actually how you make shared rides work. So pool is a really, really interesting real-time challenge, because what you have is you have an individual in a car going from, say, imagine it's my commute, right, from Crouch End to Aldgate. And what our task in that is as that car is going from Crouch End to Aldgate, how do we bring other people to sit in the remaining 2 or 3 seats? And that is a challenge that is working out second by second and minute by minute. And we need to do it in a way that optimizes not just for the riders and drivers, because obviously the more people you put in the car, the better it is for congestion, the better it is for emissions, and the better it is for riders who will pay less. But you also have to do that in a way that gets the right balance between utilization in the vehicle and convenience for the riders and drivers. So you don't take huge trips that go long distances out of the way. So the new shared rides product which we launched, which I mentioned earlier, actually what we found is one of the best ways of optimizing this in real time is to ask riders to walk up to 250 meters at the beginning and end of their journey. And when you do that, you actually allow a much more optimal solution that works for everyone, but that's a real-time solve. So we have algorithms and we have systems that are working on that sort of every second of the day across London, across millions of rides.
That really seems like a fantastic use of data to help you drive that decision about where to kind of pick people up. I noticed that in your talk, you mentioned a lot about how you see Uber as being part of the fabric of London, and it's interesting that when I think about the kind of the fabric of transportation in London, you think about roads, you think about bus lanes, you think about the green taxi driver cafes that are providing welfare support for the actual black cab drivers. Is that something that you, Uber, have thought about how Uber interacts with the actual physical infrastructure of cities?
So we have a number of sort of sites in London and the other cities we operate, which we call green light hubs, which are where drivers come in and they go through the onboarding process, and if they have queries or they want to talk with us about any questions they have, they can come on board. So there's one, if for anyone who's interested in being an Uber driver, one near Aldgate Tower. Happy to share the address afterwards. So yes, we have physical infrastructure, but obviously we're primarily a sort of virtual service, and we think that probably makes sense to keep it that way.
Obviously. So I think you've both talked about how the data that you're producing both through Uber and O2 can influence kind of planning processes and transportation planning. Obviously, Clare, working at Arup, Arup have been involved in transportation planning for many, many years using kind of existing data sets. And I just wanted to dig in a little more detail about how you as a company approach kind of managing the data that you need to kind of make those decisions.
Managing data to support kind of transport planning.
Exactly, yes. Yeah.
So it will really depend on the question and the client. We work with both big cities and transport authorities who will want to know what does it look like if we want to extend a metro line, for example. And so understanding how to access that data is always the first question and is always the hardest question. Our clients often don't know what data is available, what is actually in the data that they're promised. And so there are kind of these traditional methods that have been used for a long time, which is looking at census data, pen and paper survey data, and trying to understand what can they actually get out of new data, which isn't new, right? We've had mobile data and kind of vehicle fleet traffic data for quite some time. I'd say then that's paired with a lot of modeling work, and again, that modeling, transport modeling, is also kind of old, and that's one of the things that I'm working with our team to update, to take advantage of new ways of using data.
Can I add to that?
Yeah, of course. Yeah.
I mean, so we do a lot in this space as well, and I think it's about choosing the right data sets to fuse together, because there's so many data sets out there that really do complement each other. So, for example, we've got a really good understanding of macro movements on a large scale and obviously countrywide, but a GPS data set, for example, will give you a far better understanding of granular movements, albeit not as big data samples. So, if, for example, you put together Uber data with O2 data, we might be on something here, Jamie, by the way. Then you will have something that's stronger than the sum of its parts.
I mean, for us, I think the key thing is actually what's the problem we're trying to solve, and then the way we approach that is, if the problem is clear, then how do we have data that can help address that problem? So one of the problems we've got, which sort of aligns to our commitment to help drivers upgrade into electric vehicles by 2025, is where's the charging infrastructure? And the problem made even more real than that is that per head of population, the charging infrastructure in London is about 1/10 that of world-leading cities in the Nordics. So obviously our commitment to help our drivers move to EVs creates a problem, which is they have to be able to charge. So one of the things we're working on is how do we use data to address that problem, which is where should the chargers be. So what we're doing now is we obviously have a lot of data about where Uber drivers drive and where they stop and how they work, and we are using that data to populate and interfacing it with then the tech roadmaps of the EV vehicle providers and battery life and battery capacity, charging times, to come up with the optimal layout of charging infrastructure in London as it progresses, as our fleet upgrades, and as battery technology means that you can actually charge quicker and last longer. And you know, that then has allowed us to sort of work both publicly with some of the councils who obviously have a key role in this area of sort of creating the space where parking can also be enabled for charging, but also then private providers for whom this is a commercial interest. So that would be an example where we're using data to solve a very real problem, which is hopefully a problem that will make cities more livable, or a solution that will make cities more livable.
So I think this is just showing how valuable data is, and I'm really interested in this question about the value of data. So I think there was a lot of talk in the talks earlier about use of the word sharing of data, and I'd like to kind of explore a little more what that means in practice. You mentioned that sharing data has been part of Uber's discussions with CFL about licensing and the like. And I think, Dave, you also mentioned sharing of data. How do you view that value? Is this, for example, for O2 a commercial concern? And for Uber, part of a tax of operating in a city? Like, how does that work out?
If I answer it, so I think we, as a partner for cities, in helping people sort of get around within cities, I think it's essential that we share our data. So we've created a tool called Uber Movement, which brings together, aggregates our data, and then allows regulators and other third parties to interrogate that tool for traffic flows, traffic information, speeds, etc. That's something we make openly available. I wouldn't call it a tax so much as a desire to do the right thing by cities.
And how about you, Dave? Is that for more of a commercial proposition, or?
I mean, so we do commercialize the data when we provide it into public sector. We do charge for it, and I think, as I've explained, we don't just pull the data out of the network. There's quite a lot of platforms and processes that are required in order to get it into a usable state. So we couldn't really do that if we wanted to. And I think, but if you look at the data sources the public sector have used traditionally, we are just a very, very small percentage of the cost of some of the data sources. And if you look at the budgets that public sector have for this type of thing, they're saving a lot of money by embracing some new technologies. I think the other point to make is whatever the value of the data is today will be very different in a year's time as it was 2 years ago, and so on, because technologies and data sources and Internet of Things, there's just more and more data available every day, let alone every year. So the new solutions and data sources are quickly being disrupted.
Yeah, if I can jump in, I'm glad that you asked about sharing of data. What I think is really interesting about this particular panel at CogX is that we actually have data providers, essentially, in this room talking, where lots of the other focus on CogX is then like the use of the data. And so here we have kind of a collection of people who are both producing and then using data. And some of the other themes that have come out through the CogX conference have been about what is the responsibility of kind of everybody in this community around data. I was at a great panel yesterday in the Alan Turing Institute tent about data in areas of conflict and about the misuse and potential abuse of data. Right, that's quite a kind of intense view of how data can be used, but kind of one of the themes that came out was making data transparent, being transparent about what is in it, the provenance and intended purpose of it. Just thinking about how that then fits with something that Martha Lane Fox identified, which was that there's really lots of education needed between or for our leaders in the public sector. So there's a lot of misunderstanding of how to make use of data. And I'm just thinking about kind of, and then the responsibility, right? Climate change and the Sustainable Development Goals are, again, a core kind of theme to this conference. So you kind of have this, how do we talk about transparency? How do we talk about sharing data in a way that is, elicits consent from users of these products? And I'm just wondering what you think kind of as data providers and users, your role might look like maybe today and then,
I think that's definitely a fantastic question. I mean, Dave, you mentioned earlier that one of the reasons why O2 is keen to make this data commercially available was to empower citizens to make decisions. And I wondered how you yourselves go about the decisions about which data products to offer, what kind of data to aggregate, and how that fits into the general product planning.
I mean, obviously, the products that we offer are largely controlled by the type of data that we do have. I think the anonymization and aggregation rules also limit some of the use cases, and it kind of brings us to a place where we're providing data that's population movement focused on a very macro level. What was the second part of the question?
About the transparency angle, about how important do you think it is to explain that to the
absolutely. It's an interesting one, actually. So it took us quite a while to get our data sets accepted into public sector. So public sector have lots of policies and rules and processes about evaluating the data sets that they use. So we've talked about some of the historic data sets that are used, whether it's people with clickers by the side of the road, whether it's induction loop data, whether it's sensors. And whilst a lot of that data has got huge weaknesses, they're accepted into public sector because they've been using them for a number of years. When you are introducing a new technology, it's very important that you're very clear about the limitations of the data. So when we first started, people thought, you've got mobile phone data, you must have everything. And it isn't quite as simple as that. And obviously, we wouldn't be able to use it on an individual level anyway. So it was about getting across the message around where our data starts and stops, the use cases that it could be used for, and the data sources that could be fused with it to complement it to give a better answer. So it's important to set your stall out like that, otherwise it will probably take you another two years longer than it should do.
And I think if we look at kind of other innovative uses of data in the public sector, TfL, for example, are right now doing a lot of work around modeling population flow through stations using fine-grained Wi-Fi tracking. And as part of that process, there was a not insignificant kind of public awareness campaign through kind of posters and publicities explaining, like, this is the kind of data we're going to be collecting, and this is the use cases we're going to take. Perhaps I'd like to hear kind of from both Jamie and David, like, how you feel about that kind of proactive engagement in letting your kind of potential users know how data will be used downstream.
So we, in terms of sort of proactively, or using information to proactively reach out, an area we are very focused on is safety, and how do we use the data we have to make every single journey safer. And one of the things we've been looking at in the States, for example, is if the data shows that a car has been with a rider and a driver in it has been stationary for a certain period of time and is not in traffic, we make an outbound contact proactively to both rider and driver to check they're all right. So that's an example where we are trying to sort of use the data we have to make rides safer by proactively doing something that we can do using the underlying data.
So okay, and Dave, how is kind of O2 approaching this problem of educating your mobile subscribers about the potential downstream uses of this data?
So I think it's an interesting point, and obviously privacy is very important. Obviously, we just had GDPR introduced, so I think with the introduction of GDPR, there are less grey areas around what should and shouldn't be done, how data should or shouldn't be used. For us personally, we're not using any individual level data. There's no personal identifiable information in there. You can't reverse engineer our data in order to understand where an individual is at any point. But I think it does open up another interesting question around keeping citizens informed, because there's lots of talk around how some of these smart cities technologies are going to evolve in order for the citizens to be able to make money or to get things for their data. There's an interesting project, a smart cities project, in a place in Portugal called Qashqai, that I think it was Deloitte working on, where they've created an incentive scheme for citizens. They've got an app, and they've given all the citizens in this city, it's only 250,000 people, a phone, and they can literally go onto the app and say, right, there's a pothole in the road there, take a photo of it, send it on, and they'll get points they can redeem against public sector, and all sorts of different things like that. So people's data could well become a currency, and so for that reason, it's very important that you let them know exactly what you're doing with it.
Excellent. I think we're just about to close this panel. Probably time for one final closing remark from each person. I'd love to know what your kind of hopes and dreams are for the next couple of years of mobility in the urban environment, starting with Jamie, maybe.
So I think the key thing for me is that the goal we have of trying to help people replace their private car with their phone is not going to happen unless we get deep cooperation across both the public and private spaces. So this is a big ambition. I think we will all be better off as a result, but it's not going to be done by one company or one person alone.
Dave?
I think when I look at smart city technologies, I don't see any reason why we can't completely get rid of congestion within 10 or 20 years, and I'd love to see that happen.
Claire?
Every city that we talk to wants to increase active travel, so that's helping people cycle and walk for most of their trips. So figuring out how to do that and how to make things like congestion charges actually effective. I don't know that it's simply replacing a personal car with an app. I think that may be one piece of a larger kind of infrastructure and overall system design to encourage people to travel using cleaner technology, really.
Excellent. Round of applause for our panelists.
Thank you.
Thank you.
How are you guys all doing? You surviving without Wi-Fi? Yeah? All right. We've got one last panel. And while the turnaround is happening, Andrew will be leading that panel. And for me, I don't know what you heard about this, but sort of congestion, collaboration, cycling, and walking
Yeah, definitely.
are the hopes for the future.
Yeah.
The speakers from this panel will be leaving, and you can obviously go talk to them. But I encourage you to stay for this last panel, and then you can go talk to all 6 speakers at the very end. It's also a lunch break from 1:45 to 2:30 before the afternoon sessions start in here. So can I get the next group of panelists to come up here, please? Do you want to go to the back, guys? We're hearing, if you go to the back to get your microphones on. Yeah, just there, through there, yeah. Should we do like a bit of a song and dance routine? Tell me about Google Maps, like all the data that you guys sit on. Hold on for a sec, I'll get your microphone on. 2 minutes. Guys, can you be quiet, and can you put Andrew's microphone on? It's on, all right. Okay. All the fun part about the changeover, seeing as there's only one way in and one way out, which is kind of fun. So data and Google Maps, and data with what you're doing with DeepMind. I mean, that's core to what you're doing. So I'd love to hear more about that.
One of the reasons why I'm so interested in the role of data and the urban environment is obviously Google Maps. We have the traffic layer. You can turn on a layer in Google Maps and see how busy the roads are. And many people tell me that is ultimately like changed their life, that is cut hours off their commutes from being able to understand how busy roads are. And when you think about it, the amount of data that you need to estimate something like the traffic layer in Google Maps is relatively small and it's not particularly identifiable. You just need the average speed of a car going down one particular road. As you get more into the details of more complex urban environments, more advanced infrastructure, you start needing more and more data about people. And then so I think it becomes a very interesting question about like, how do those decisions happen? Who gets to decide how data is used in these environments?
Yeah, and it was really interesting listening to the other CDO panel and how they consider the use of data and AI. So thank you for that really cool insight. I'm hoping that the panelists are mic'd up and ready to go. Let me just zip backstage. Are you guys ready at the back? Yeah, do you want to come on out? Okay, final panel. So over to you, Andrew. And this is about data and services, which I think should be super fascinating.
Yeah, so I would like to introduce Samar, Ed, and Jennifer to the stage. Perhaps the best way to start would be a quick 1 to 2 minute pitch of who you are and what are you doing at CogX on this panel today, probably starting with Samar.
Sure, thank you. So guys, I run a company called Jugnoo, which is an on-demand aggregator for auto rickshaws. So small tuk-tuks, three-wheeler taxis, which are very popular in India. So it's similar to Uber and other apps, but just to get a tuk-tuk instead of a taxi. And recently, what we have done is we have actually diversified into our platform as a service. That in the way that people essentially all over the world are now running their own businesses on top of the app, which is like a big differentiator from the other apps which are essentially a top-down approach. So that's what we do, and we are hoping to launch even in England through this different model. And I'm here to study the market and see how good or feasible it is to launch something here. And yeah, thanks.
Excellent. Ed, tell me about Scape.
So I co-founded Scape Technologies about 3 years ago, and essentially we allow devices to understand where they are and what's around them using a camera. So if you fast forward to what the world looks like in 5 years' time, we're going to have augmented reality devices, we're going to have robotics, we're going to have semi-autonomous cars and drones. And all of those devices essentially need to know more about their environment than ever before, and the degree of fidelity that they need we can't currently provide with existing technologies such as GPS and compass and whatnot. So we've provided a pipeline that allows devices to recognize their location with an incredibly high degree of precision using a camera. And we provide essentially an API that allows you to send our system an image, and we return back a very accurate location and orientation of where that device was taken.
Excellent. And Jennifer from Humanising Autonomy.
Hi, at Humanising Autonomy, we developed a software to understand behaviors of people and predict their intents to make autonomous systems safer and more convenient to communicate with. To give you an example, today it's already very good if you know that there is a pedestrian, that this pedestrian is maybe moving, and where this pedestrian is compared to a vehicle. At Humanising Autonomy, we go inside that bounding box and understand if that pedestrian is distracted by an iPhone, for example, or talking to another person, and if this person is about to step onto the road or not. Me as a cyclist, for example, I know in a split second if this person is going to cross the road, if I need to slow down or speed up, and I can navigate central London very efficiently and safely. And at Humanising Autonomy, with our software that uses computer vision and behavioral data science, we capture some of that kind of human superpower that we have today to integrate in autonomous systems.
Excellent. So I'm super interested about the different kind of types of urban environment these technologies operate in, and kind of how that affects the development of the technology. We just had Jamie from Uber on the panel. Uber have been operating in London and had, as Jamie described, a difficult year in kind of dealing with local government and the restrictions and constraints around what are the emerging constraints and laws around operating rideshare services. Samar, perhaps you could tell me a little bit about how that has happened in your expansion of auto rickshaws. Do you see a similar thing, or is the kind of your Indian market quite different in terms of adoption of new technologies?
Sure. So actually, the market is very different when you go to any developing market. So the biggest difference is actually that the regulations are not really clear, even though they are defined, but they're not followed. So for example, if you go to India, nobody would really follow a fixed fare, right? You're just expected to haggle every time before you hail a ride. And what it means is that actually authorities are very pro ride-sharing services, because customers are being overcharged by the drivers, and the moment somebody steps in who regulates those issues, so authorities are actually fairly okay with it. And the second thing is, we are not really stepping on somebody's toes in the traditional sense, because the most regulatory issues are created because the taxi unions are against ride sharing services. And if you go to India, it's a different story, right? I mean, there are much more taxi or auto rickshaws than demand, so people are pretty okay with this new technology. So in a way, it's you can think of this trend as leapfrogging of a traditional taxi infrastructure. So essentially, it's very difficult to hail a taxi on the road, which is not an app-based taxi today, right? And that's I think the biggest difference, because in the developed world, you can actually hail a cab or a cab anywhere without an app, but in India, actually, it's almost impossible to do that. So it's essentially leapfrogging the traditional infrastructure creation.
Yeah, that's super interesting. In another case, kind of leapfrogging infrastructure, I mean, we, autonomous vehicles has long been the savior in the tech industry of many urban problems, but then, actually deploying on those streets have been like relatively slow. And yet actually that technology has huge potential. So perhaps, Jennifer, can you speak to a little bit about how some of the kinds of technology that you're working on can actually help improve the safety of existing systems?
Yeah, I really appreciate that question. If we think we have a zero vision that we want to achieve, zero accidents by 2050, might be wrong to wait for fully autonomous vehicles to achieve that. And so some of the ways that our software is being used today, for example, is as part of advanced driver assistance systems. So to help drivers today to detect pedestrians and cyclists and general vulnerable road users, and support them in driving, basically. So we've just showcased a product in Michigan with Ann Arbor Public Transport Authority, where our software will be part of a bus and supporting the bus driver and alerting about dangerous situations. And another opportunity, I think, for these artificial intelligence softwares is in the intelligence transport ecosystem, kind of in the vehicle to infrastructure communication. So we are working on a project in Japan where we want to make crosswalks safer. An autonomous vehicle can still not look around the corner, but if we have this technology in roadside infrastructure communicating with pedestrians, with drivers, and in the future with autonomous vehicles, we can alert everybody in the surrounding system about a dangerous situation ahead. I think these are...
Is it interesting that you're actually thinking about how that would physically change the environment rather than just the software that sits on top of it? And Ed, obviously, Scape has done amazing work in modeling the world, and I think typically when you see these high precision 3D modeling technology demo videos and the like. They're typically autonomous cars driving around suburban America, around Phoenix. And everybody who's walked around at this conference, the King's Cross environment is a very different style of environment to suburban Phoenix. There are very few things that traditionally look like a road. I'm wondering how you, being a London-based company, have approached that modeling the new kind of urban environment, which is not really car-centric necessarily.
Got it. Well, just to illustrate why accurate location is so important, we've all experienced it when we've come out to the tube station. We've looked down at our phone and our blue dot is jumping around, and it's only after we've walked halfway down the road and turned around several times that we actually know which direction we're going. Now, for us, that's an annoyance, but for a self-driving car or a robot or a drone, that could be catastrophic, right? And the reason why that happens is because of these things called urban canyons. And actually, we have them in London, we have them in Manhattan, we have them in big cities around the world where tall skyscrapers essentially bounce the GPS signals between them, increasing the inaccuracy of your location. That's in terms of the GPS. And then for the compass, actually the steel and metal inside buildings around you is affecting what's called a magnetometer, which is actually in the device itself, which it uses for the compass. So the challenges that we're faced with for accurate location is actually amplified in these dense urban environments where the technology that we want to exist, self-driving cars and whatnot, are actually most needed. Now, in order to solve that challenge, behind the scenes of our visual positioning system, we've essentially had to build a large 3D map from imagery. And inevitably, you're going to have a chicken and egg problem with a visual positioning system, because unless you have built a map of a particular area, you don't have anything to compare against. And when we started, there were only 3 companies in the world that had the type of density or quality of imagery that you need to build these types of maps. And they were Google, TomTom, who've been working with Apple to create their maps for several years, and a company called Here Maps, who's now owned by a conglomerate of car companies. But essentially, none of them would give that information, that data away freely, because it was so valuable for what they need to build the foundations for self-driving cars, augmented reality, robotics, and so on and so forth. So one of the challenges that we had was we had to overcome that chicken and egg problem. And we did that by collecting our own data sets of map data in over 100 cities around the world. And we did that in less than a year with a fraction of the cost and time that it would have taken a company like Google to create, because of the way that we structured our data collection and data processing pipeline.
That's super interesting. So I know that both Jennifer and Samar, you touched on the relationship between technology and regulation there. Samar, you talked about how actually authorities were very interested in ride-hailing technologies because it gives them a vector to control a market that wasn't there before. And Jennifer, you mentioned about how this technology can be used to improve safety, and obviously safety gets very close to being a regulated industry. And so I'm really interested in how your 2 companies are approaching those conversations. So what are you thinking about as you enter conversations with kind of city governments? Like, how do you balance their desires against the desires of the users who are using your service? Perhaps starting with Samar.
So I think there are 2 aspects to regulations, right? I mean, one is of course safety, and there shouldn't be any corners cut, and we as a company have to really put safety first, right? Because even though, as a market, India is not really focused on safety, right? I mean, cost is the biggest driver of product consumption, but at the same time, as a company, we have to put safety first. So, but other aspect which is kind of odd is that there's a lot of regulation which is actually designed to save or safeguard the legacy system, right? I mean, you talk about taxi systems, or there's a lot of regulation that would say that would try to safeguard the government monopolies, like bus systems which are in place, which aren't making money, and the government still wants to save them for political reasons and stuff. So So I think that is the regulation which is tricky to deal with as a startup, because it's fairly illogical and pretty much everybody knows it, but it's just that because of the shift, because of that economic force has to happen. It's just that nobody wants to be the bad guy pulling the trigger. So in that case, I think startups need to. So at least in India, what we do is we combine forces and try to lobby, and really just reason with people. It takes time, but slow and steady, we are getting there.
And Jennifer, how do you see the technology that you're working on interacting with regulated spaces?
I feel like we're at a very interesting point where we see, for example, the European Commission has just published an updated vehicle safety and pedestrian safety regulation, where it sees buses and heavy goods vehicle kind of have pedestrian detection and cyclist detection mechanisms on their car as kind of mandatory, and I think that's I like this kind of step-by-step approach to autonomy, and what we are doing with our project and with our technology, I think, fits very well into that step-by-step approach, where you can break it down and use parts of our software, of our artificial intelligence, to solve issues like accidents by buses that cost a lot of lives. And also kind of, I think when these systems get safer, we can also promote kind of more active transport, I think, and if that's also in the interest of cities, that making transport systems inside the city safer can kind of support many regulations that cities are trying to get around, so get people to walk, to cycle, and also support new transport modes. So you have, I would say in the future, a lot more vulnerable road users with scooters, e-bikes, and I think cities will have to kind of dig down onto these step-by-step regulations for introducing these new technologies on vehicles. To support these modes of transport.
Certainly, the desire to increase active transport in cities for health problems is a huge trend. I think we'll be seeing in the coming years. Now, Ed, obviously you're downstream of a lot of services because you're building out what I understand to be a technical positioning platform. But obviously, anytime you build out a technical platform, it's got some really interesting trade-offs there in terms of. For example, how do you think about restrictions on the use cases that the platform could be placed upon? Are you, guiding autonomous vehicles seems like a really good idea, but perhaps there are other use cases you wouldn't necessarily be comfortable using your service with. And also in terms of kind of coverage, what you often see in kind of new technology products is that they work perfectly in dense urban environments like London, where you have 10 million people who are a captive market, but then you move outside into the countryside where perhaps the market economics don't quite work, and then suddenly you don't have services anymore. So how are you thinking about those?
Yeah, quite right. It's always a challenge when you're building for a future that doesn't quite exist yet, and you're having to make predictions over how that future looks. And as I talked about the various different industries, we're entering into an era of something called spatial computing, which is basically the movement from computers or devices that we've accessed behind a 2D rectangular screen to a device that sits in and lives in the world around us. And that could be anything from drones, robotics, autonomy, blah, blah, blah. However, all of those different industries have various timelines associated with them. They have various distribution opportunities that you can target today, and they have various different safety risks as well. Now, we've chosen that out of all of those industries, one of the main industries that we're targeting is augmented reality. And that's because there are 2 billion people with smartphones sitting in their pockets that can build the type of infrastructure will essentially lay the foundations for everything else that is yet to come. But yet, today, there still is not a killer application for augmented reality. So we have to work with the opportunities, we have to partner with other companies who fill out some of the rest of the ecosystem. And that includes people who are actually creating products in their own right, whether that's applications or anything else, or handset manufacturers who are actually getting this into people's hands in the form of hardware. Now, you asked about whether there are use cases of this that we would or would not support. We've tried to make our API or services as generic as possible, but that will obviously stop at a certain limit. When you're working to put a car on the road and drive people from A to B safely without any intervention from a driver, you need to go pretty deep to make sure that that is working as optimally as it possibly can for that particular use case. In the same way, people you could see opportunities to use this type of technology in warfare, for example, being able to identify where someone is and therefore display where other people are around them very accurately. However, with that example as well, you're going to have to go a pretty long way to ensure that your generic solution is optimized for a particular use case, and we'll take it on ourselves to decide which of those use cases we want to proceed with and which we do not.
So you, at the moment, you are making a case-by-case decision about whether or not you allow a particular usage of the...
Yeah, we're working very closely with any of the partners that we work with, exactly.
Just picking on one comment you meant that, you said that both, one of your kind of key target use cases there is augmented reality, and yet you don't believe there is a killer application out there for augmented reality yet. Do you think, do you have an imagination of what that could be? What makes you so sure that that is the direction to be going?
I guess the closest thing to a killer application that we've seen with AR is, of course, may I say, Pokemon Go. Over the few days that Pokemon Go is released to the public, the market cap went up by something like 13 billion, and in the first month it generated $100 million. It's now raised or generated well over $2 billion worth of revenue. That is as close as we've got so far. But really what we're talking about is we're getting, augmented reality is all about getting the graphical user interface into the real world and removing that layer of abstraction that we use when we use our mobile phones or our screens. Now, it might be that we are waiting for a new form of display technology that will allow us to do that, i.e. headsets. But I do think the work that people do to uncover the product innovations are going to happen on the mobile phone first before transitioning over to the AR headsets themselves.
That's so good. I think we're about at the end of time for questions of this panel. I don't want to eat into people's lunchtime anymore, especially since it wasn't raining when we came down here. I'd just like to end with one question for each of you on the panel, which is, what are your hopes and dreams for the next 2 years and where you would like to see your field? Starting with Samar.
From a India perspective, I think we are actually hoping to be where the world is already there. So I think there's a long way to go. But at the same time, I think what we really want to do is make public transport or mass transport safe in India, because if you look at the ratio of cars that UK or US has. In terms of population, it's never going to be possible for India. So India, if it has to be, a proper society, it has to bypass private car ownership and get into the shared mobility as a service era. So I think that's what we are working towards. And in 2 years' time, I think, and in fact, this year, it's till this time, car sales are down by 17%. Even though it's an alarming number for economists, guys, but I think it's clearly shifting towards mobility as a service trend. And I think in the next 2 years, if we can really decrease the car ownership, I think that's where we are hoping to be as a company.
So, Ed?
If I might expand the time frame a little bit before working our way back, I mean, what we're really trying to do is to fill in the missing piece of infrastructure that connects devices to the environment in the same way that the internet connects them to each other. Now, over the next 2 years, we're going to see a huge amount of additional hardware and distribution opportunities, different form factors of devices that can actually start to lay the foundations that will allow that to happen, whether that is in Apple's AR headset that they're supposedly going to be releasing, or new vehicles that are traversing the world, capturing that data and laying those foundations for devices to come after this.
Jennifer.
I would hope that we can make these new transport, the software that goes into future transport systems, as inclusive as possible, and that kind of includes all different cultures. If we think about where autonomous vehicles are being tested and where data is being collected at the moment, it does not cover every part of the world. And then also if we think about all the new transport modes that are kind of sprouting up everywhere, I think it would be important for these future transport systems to include these as well, to actually make them safe.
Excellent. Thank you very much, and thank you very much for joining us.
Thank you.
Thank you.
Thanks, everyone.